Hello, my name is Mofi. I'm a developer relations engineer at Google. In this video, we're going to learn all the different fields you can set in Kubernetes jobs and what they means. Let's get started. In Kubernetes, changing the jobs API field lets you control the behavior of the job. The first field we're going to talk about is spec.suspend. This specifies whether the job controller should create a new pod or not. The next field we're going to talk about is spec active deadline seconds. This field defines how long the job is allowed to be active before Kubernetes controller tries to terminate it. Suspending a job resets the timer. Let's look at an example. Here we have a job called the deadline, which has an active deadline seconds of 10. And we're running a Perl command that sleeps for 1,000 seconds. On the right-hand side, we will run a watch for all the pods. Right now we have nothing. Let's apply this job. We'll see a new pod gets created, which is now running. And about in 10 seconds, Kubernetes will start terminating because that exceeds the deadline. And you can see the job is terminating. Next field is the backoff limit. Backoff limit defines the number of retries before a job is considered failed. By default, that number is set to 6. You can set it to any number depending on your need. Let's look at an example. Here we have a job called backoff, which is a backoff limit of 2. And the container is running a Perl command that exits with an error message, exit 1. So to Kubernetes, this particular job has failed. Once we apply, we'll see a new pod gets created and immediately returns status error. And because of the limit, it starts a new pod to retry again. It fails twice. And since the backoff limit is reached after retrying 2 more times after the first time, Kubernetes now will no longer try to create this job again. We can see the status of this job with kubectl get jobs. And we will see backoff has 0 completion. If we do kubectl describe job backoff, we'll see that job has reached the specified backoff limit. The next field we're going to talk about is spec completions. Spec completions define the number of pod executions required to consider the job complete. You could use a higher completion value than 1 to run multiple copies of the job. If the completion value is set to nil, then any completion would be considered a job success. Setting completion to any value limits the number of parallel execution you can have by that number minus the number of successful execution you already had. Let's look at an example. Here we have a job defined called completion with completion's value set to 4. Kubernetes will execute the pod 4 times for this job to be considered complete. We can run the job with kubectl apply -f completions.yaml. We'll see that a first copy of the completion job is running. Once that is completed, Kubernetes will spin up the second copy of that pod. Once all the pod has finished running, we can see that kubectl get jobs gives us a completion of 4 out of 4. So our job is now completed. We can see an example of multiple pod completion where the completion value is set to nil as well. In this example, we have a job where parallelism is set to 4. That means Kubernetes will try to spin up 4 copies to execute this job, but the completion value is not set. That means any of the 4 pods that Kubernetes spins up, finishing successfully will mean the job is successful. In the command itself, we run a Perl command where it sleeps for a random number between 0 and 20 seconds. And you can apply this job with kubectl apply -f completions multiple. We'll see that our job has a completion of 0 of 1, and multiple of the job has finished. So our job is now complete, and you can see our completion is 4 of 1. That means only 1 was needed for our job to consider it complete, but we finished 4 of them. Next, we learn about spec.parallelism. We already learned about parallelism in the previous example. Parallelism defines the maximum number of pods the job should run at any given time. The value is limited by the value of completions minus the number of pod in the job that has already been successful. Let's look at an example. In this example, we could see a job with completions value set to 4 and parallelism value set to 2. When we run this job, Kubernetes will spin up 2 pods at a time until 4 of these pods have been successful. We can run this with kubectl apply-f parallelism.yaml. We'll see 2 copies of the pod executes right away. Once they're completed, 2 more copies of the pod get spun up. The next value we're going to learn about is completion mode. This is how a completion of a job is tracked. So far, all the jobs we have been running have been non-indexed. When a job has been completed, spec completion's amount of time. There's a different completion mode, which is very useful for jobs that depends on each other. These are called index jobs, where each job gets an index from 0 to spec completions -1, and the job is only complete where each of those index has completed successfully. Let's look at an example. This job is a bit more complex than all the examples we have been looking at so far. We'll come back to the service part in a second, but let's look at the job portion. Here we have a job called example job with completion and parallelism both set to 3. The completion mode is set to indexed, and we have a subdomain of headless service. What we try to do from the job itself is for each of those index and for each of the job instance, we try to ping all other jobs. And if we successfully manage to contact them via network, we consider the job completed. This use case is very common for things like MPI jobs or some machine learning distributed training happening where all the pods need to communicate with each other. At the top, we define a headless service that gives each of our pod a fully qualified domain name to be accessed using the Kubernetes network. We apply this job with kubectl apply-f completion-mode.yaml. We'll see a new service gets created called headless service, and we have all of the job completed. We can look at the log of one of the jobs with kubectl logs name of the pod. We can see that in the beginning, we had one failed to ping. After that, the pod ping was successful. The next field we're going to learn about is TTL seconds after finished. This value limits how long a job is kept around after the job has finished. By default, a job is kept until it's manually deleted. With this field, you can clean up the job after a certain amount of time. Let's look at an example. So we have the same exact example, but here we clean up the job after 10 seconds has passed. Let's apply this job with kubectl apply-f TTL, and you will see a new job has been created. Job is running, and the job is completed. And in about 10 seconds, Kubernetes will then consider this job completed and clean up this job. We can see the job is now deleted after 10 seconds. The last and final field we're going to learn about job is spec.template.spec.restart policy. This field defines what should happen on container failure within the pod. This is a required value for job definition, and the only valid values are on failure and never. Even if you set the value as never, backup limit value will determine how many times Kubernetes tries to rerun the job by creating a new pod. Thank you so much for joining us for this episode. If you have any more questions, please drop a comment.